So, welcome back again. So, today, as I said in the last class, we are supposed to learn about combinations. So, combinations is actually a special case of permutation, where you want completely different things. For example, the Indian cricket team. If I make a list of the Indian cricket team, I don't care who stands here and who stands here. And I don't care if Dhoni stands in the middle also, right? They could stand anywhere. Dhoni could stand here, Dhoni could stand here also. It doesn't matter. What matters is they are there in the Indian cricket team list. Right? What matters is they are in the Indian cricket team list. So if I write a list of people in the Indian cricket team, they are there. And that is what matters. It doesn't matter, where Dhoni stands here or Dhoni stands there at the last. It doesn't matter. Likewise. So that is, so here the order doesn't matter. You see, the order doesn't matter at all. Another case, example, if you have two friends, it doesn't matter which way you write them. For example, if I say my friends are Ashish and Joel, it doesn't matter if I write it Ashish and Joel or Joel and Ashish. It just matters that two names are there. So the order doesn't matter. If Vinny stood here and stood here in the left side, it wouldn't make any difference. So it's just that the order doesn't matter in a group of friends. Another example, the factors of 48. The factors of the number 48 are 1, 2, 3, 4, 6, 8, 12, 6, 24 and 48. My friends, it doesn't matter in which way you write them. This is written in the increasing order of numbers. Even if you write it in some other form, decreasing order, or even if you jumble it up, it is not going to matter. What matters are we need the factors of 48. That is all. So in these cases, the order doesn't matter at all. And such cases we call combination. Such kind of things we call it as combination. Now, let us use our pin code example again. If I don't care about the order, then 1 2 3 4 4 3 2 1 2 4 3 1 3 2 4 1 are all the same, because it is just putting it up different ways. If I care about order, this all four are different things. But if I don't care about order and I say, oh no, I want a very strong password, then it's all the same. If I don't care about order, all these things, there are more possible. I can write as 2 3 4 1 1 4 3 2. There are more. I have just written 4 here. So if I don't care about order, all these things are the same. So we know that how many ways of writing, how many ways are there? 10p4. Total number of numbers of 10 and 4 options. So 10p4 ways are there to find. But if there is a person who doesn't like order, then for him it is overcounted. Because for a person who doesn't care about the order, these all are the same. These all appear the same to him, because it is just jumbling up the letter. He wants completely different things. So for him it is overcounted. 10p4 is a greater number than what he actually needs. So we need to decrease it. We need to divide by something. With what? Let us see. We need to divide by. So if I take any 4 numbers, how many arrangements can I make with those 4 itself? For the total 4 numbers and 4 options. So I can have 4p4 ways. I have 4p4 ways of arranging every 4-digit number, every 4-digit pin code, every 4-numbered pin code, right? When I have 4 numbers, I can rearrange all these 4 numbers by 4p4 ways. So I will just divide by that. So because I don't want any rearranging, I want proper different number pin codes, I will divide the whole possibility, that is 10p4 divided by 4p4, and it will become 10p4 divided by 4 factorial. 4p4 is 4 factorial, right? Now let me just open this up. 10p4 is, now by the way, 10 is what? Our n, number of elements. 4 is our k, number of options. So I can generalize it and write it as, and this 4 is also k, same number, right? So npk divided by k factorial. Now if I open the npk, what happens? N factorial divided by n minus k factorial whole divided by k factorial, and if I solve it, it becomes n factorial divided, if I just making them in the common denominator, it becomes n factorial divided by n minus k factorial into k factorial. And my friends, this is what is called the formula for combination, that is nck, n factorial divided by n minus k factorial into k factorial. So this is the formula for combination, n factorial divided by n minus k factorial into k factorial, also written as nck, because again and again we might have to use this. And so for a acronym means short form. For a short form, we use this symbol called nck, where n is the number of elements, total number of elements, and k is the number of options. So now let me show you one example about it. Here I am thinking of showing you an example regarding combinations. Now here, I have already told you whether I'm going to show you permutations or combinations. So basically you don't have to identify whether it is a permutation or combination. I'm sorry, but when you read a question, you have to understand whether you really have to apply permutation or combination. I mean, even if the question doesn't require you to do that, you need to understand for your understanding in math. So let me put for the question, and this one question I think is enough to make you understand. That is example 21 in your maths textbook. So please refer that. While I'm saying, please go through that. Don't go through the answer, of course. I mean, you can go through it after the lecture, but please go through the question. A group consists of 4 girls. Okay, let me write it. A group consists of 4 girls and 7 boys. 7 boys. Okay. Now, in how many ways can a team of 5 members be selected? I see. So there are totally 11 people here, right? Girls and boys together. And they need a team of 5 members. So, what are the conditions? Number 1. How many ways a team of 5 members be selected if the team has no girl? I see. So it is boys only group. So how many ways? So we know that there are 11 people in total, 4 girls, 7 boys. Now to make a group, first let us see whether it is permutation or combination. Let us take 2 boys, okay, since the question is already in the side of boys, let us take 2 girls now. And let us take, for example, whom I should take. Let us take Kushi and Shruti. This is if the team is 2. Suppose it is a 2-member team. Okay, suppose you can just extend it to 5 member after you understand this. Suppose there are two-member team and two members are Kushi and Shruti. If according to permutations, the order is very important. That means this is one combination, and next one other combination will be Shruti and Kushi. Because see, order is very important. See, for example, numbers 1 2 and 2 1 are two different numbers, 12 and 21. Permutations is very important. I mean, permutations order is very important. So in this we apply permutation. But in this team, Kushi and Shruti is in one team. Then another person comes and says Shruti and Kushi is another team. What is the difference? The same people, right? So permutations do not work here. I mean, if you apply permutation, you overcount. So what comes? The order doesn't matter. The order doesn't matter. So this is a combination question. Therefore, I hope you understood that. Let us come back. So we have a team. We need a team of 5 members. And the first question is boys only group. So how many boys? So when we have to make a boys only group, we need not consider the number of girls, right? Because our elements or our sample space, comes here. It's only here now, because we only have to select from the group of boys. So there are 7 boys in total. Fine. And we need 5 people. So it is, remember the formula? The formula is NCK. And number of elements, we have 7 boys, out of which you have to pick out 5 boys. So 7C5, that will be 7 factorial divided by 7 minus 5 factorial, 2 factorial into k factorial, that is 5 factorial. 7 factorial divided by 5 factorial into 2 factorial. You can always find the answer. The answer I'm not going to tell you. So that is one for the first question. The other question, second question, let's go to the second part of the question. The second part of the question is, at least one boy and one girl. Now it gets difficult. At least one boy or one girl. Okay, so our sample space, changes. We cannot have it like this. It doesn't become a boys only group now. It becomes the whole group. How will we call it? So we have 11 members, and from these 11 members, we have to take now. So so let us go back. So how many ways are there? How many ways are there? Now to have one boy and at least one boy and one girl, and we know there are 5 members. So the many options are there. One option will be one boy and 4 girls. 1 plus 4, 5. Second option would be 2 boys, just keep increasing the number of boys. 2 boys, 3 girls. Third option would be 3 boys, 3 boys, 2 girls. And fourth option will be 4 boys, 1 girl. Next option, there's no next option. Okay, so in all these options we see that there is at least one boy and one girl, and so these are the only options that we have. So let us go case by case. Let us go for this first. 1 boy, 4 girls. So team members is 5. So our 1 boy, 4 girls, in our samples we have to take the whole number of boys and girls. So our NCK becomes 11C. And how many people do we want? How many people do we want? We need 5 people. Okay, we'll take 5. Oh wait, will this work? This can give you even the answer of 5 girls and just 5 boys also. So it doesn't work. It overcounts. So what you can do is so there are 2 ways to approach it. I mean, one thing is, you can for example, I'll tell you the difficult way first. One way to approach this is, we know that you need at least one boy and you need at least one girl, right? So so the first option was one boy and four girls. So the number of options to choose a boy is, there are five boys in total. Sorry, seven boys in total. So 7C1. This is the combination of choosing one boy multiplied by the combination of getting four girls out of how many girls in total? Four girls. So 7C1 into 4C4. This will give you the combination of one boy and four girls. How many teams you can get like that? Then you can do the same for two boys, three girls. Next option, two boys, three girls means two boys 7C2 into three girls 4C3. Then three boys, two girls, so 7C3 into 4C2. You can just go on like that and find it. That would be one way of getting it. But I would say there's another easier way to get it, and that is, first you find all the teams that you can get. Just find all the teams that you can get. And since it's a combination question, the order doesn't matter, so it's a very easy one. That means 11. You have 11 you have 11 members in total, boys plus girls, and you need 5 members for a team. So 11C5, just see how much you get. You will get some number. 11 into, I'm sorry, 11 factorial divided by, I won't do the calculation, I'm saying it again. So it will be 11 minus 5 factorial, that is 6 factorial into k factorial, that means 5 factorial. So you get this much number of teams, 5-member teams. Now the question is that at least you should have at least one boy or one girl. Take the opposite. The only cases where at least one boy or one girl case doesn't work is when there are 5 girls and there are 5 boys. That means the girls only group and the boys only group. So only in these two cases that condition gets invalid. In all other cases there's at least one boy and one girl, right? So just find the number of teams that you can make and subtract 2 from it, because only 2 cases are there where there are fully girls or fully boys. So just find the total number, subtract 2 from it. I would say that is the best way to, that's the easiest way to find the answer for this question. So again, it is based on how you think, how you think, that is how it changes. That is how you get to find. So if you follow the standard method, you would have to go through each combination. But if you go and think out of the box kind of thing, you will get to know that there are other ways to find. Okay, now let us go to the third part of the question. The third part of the question is at least 3 girls. At least 3 girls. So at least 3 girls means there are 2 possibilities, and the 2 possibilities are 3 girls, 2 boys, and 4 girls and 1 boy. Only in this case there are at least 3 girls. So here you will have to I think use the standard way, that is find the combination of girls, that is 4C3 into 7C2. This will be the first case. Next case will be 4C4 and 7C1. 4 girls and 1 boy. Then add the number of possibilities. Find number of possibilities here, find the number of possibilities here, then add them. You will get the total number of possibilities. So I would say that is a way of doing it. Oh wait, at least 3 girls means it could be a 5 girls team also, right? 5 girls team. Oh, I forgot that. 5 girls team. So you should also add the 5 girls group. That means it would be for I'm oh wait, there cannot be 5 girls, so it is fine. Yeah, I'm sorry, there cannot be 5 girls because there are only 4 girls. Less number of girls, I see. You guys don't want to play in any sports, huh? Okay, anyways, so what is next? Problems. So just solve problems, different sort of problems. Solve the ones that I gave in the assignment. If possible, I would suggest you to solve things that are not there in your assignment also. Go through your textbooks, look at the examples, look at the miscellaneous examples, understand them, see how they deal with each situation. Because in each situation, we need to, you see, basic, this is, see, the aim of this chapter is not just knowing the formulas NPK and NCR. No, not at all. The aim of the chapter is fulfilled when you can see each situation and apply and find the number of possibilities, or at least you can find the method to find the number of possibilities. If you can find the method, beautiful, the aim of the chapter is fulfilled. My aim is fulfilled. So please try to understand the situation and try to do according to that. And again, thank you for listening to me. If you have any doubt, please contact me. And yeah, that's all for today. Thank you.